This is section 2.9, and here we're going to study combined variation and joint variation. Combined variation occurs when both direct and inverse variation occur together. Joint variation happens when we have two or more direct variations happening together. So for an example of combined variation, let's do that first. Combined variation has both direct and inverse, and a good example is right here. Here, hopefully you can see c varies directly to t and inversely to m squared. So if I want to find k, I'm going to plug in values for c, t, and m. Let's go ahead and do that. c is 90. K I don't know yet. T is 6. And m is 2. Now I'm going to go ahead and simplify. And in my denominator, 2 squared is actually 4. And now I can solve for k. If I multiply both sides by 4, I'm going to get 360 equals k times 6. Divide both sides by 6, and I'm going to get k equals 60. My next question asks me to actually find c when t is 8 and m is 10. So now I'm going to plug in t, m, and k. And so let's see, I have c equals, my k value is 60, my t value is 8, and my m value is 10. Go ahead and simplify, and in your numerator, you should get 480, and in your denominator, you should get 100. So if I divide 480 by 100, hopefully we all get the same answer of 4.8. All right, let's take a peek at joint variation. Oop, not yet. Let's do one more with combined variation. I'd like you to go ahead and try to write in words this variation right here. Hopefully you told me that m varies directly as t and inversely as d squared. Now, if we know m, t, and d, we can find k. Let's do one more example of that. I'll go ahead and plug everything in. If m is 160, k I don't know, I'm going to find it. T is 100, and d is 5. Let's go ahead and simplify. In my numerator here, 5 squared is actually 25. And 100 divided by 25, hopefully you'll all agree, is 4. Divide both sides by 4, and I get 40 equals k. Now I have found k, and I can move on to find m, t, and d. I'd like you to try these 3 questions on your own, and when you're done, pause the video, find m with the value of k, and the values given, t, and then d. And then when you're done, press play and I'll give you the solutions. We'll see how we did. All right, have you tried it? These are the solutions you should have found. If you have questions, please mark them now so you can ask me in class tomorrow. Now let's try some joint variation. Notice that here, v is just a second. V is varying to both r squared and h. Notice that the volume of this cylinder depends on both the radius and the height. What would our k value be here? That's right, 3.14. Pi in this case is k. So you've kind of been using k for quite a while now and just didn't realize it. This is a great example of joint variation that we use quite frequently. So if I want to find v when r is 6 and h is 10, I would plug in, I'm just going to use 3.14 for pi. I'm going to plug in 6 for r and 10 for h, and you can simplify. I'll leave that simplification to you. How about the volume of a box? Do you agree it's going to be length times width times height? In this case, what is your k value? Hopefully you agree your k value is 1. And if so, you'll agree that it's also joint variation. All right. I don't need to have you do that. For tomorrow, I'd like you to read this section and bring in the covering the reading for me. I'll see you tomorrow.